Is it recording? Did anyone get the notification?
Yes.
Yes.
Yeah, we're good. Yeah.
Perfect. Okay. Welcome to the Dapr community call number 81, May 3rd, 2023. My name is Nick Greenfield. I'm a Dapr maintainer of the documentation repo, and I'm going to be the host for today's community call. So for today, we have some really exciting topics. We have a full agenda, so we're going to get right into it. We're going to start off by passing it over to Mark, who's going to give us an update on KubeCon EU 2023 and Dapr's presence there. And then Sam will walk us through service invocations. Is a new feature that's coming in 1.11, which is a service invocation of calling non-Daprized endpoints. So really exciting to see that. From there, Nyemade is going to talk about what's next for workflow, which is a preview API or alpha API, I should say, that was released in the 1.10 version of Dapr. So we're going to talk about what's next for workflow, and then take a look at a new workflow demo that really shows off the durability of workflow. From there, Archer is going to talk a little bit about different variations of the Dapr sidecar and how you can build those. And then lastly, we're going to pass it back to Mark, who's going to provide a update on some just Dapr in the community, some show and tell that we've seen, Dapr mentioned throughout the community. So, and if there's time, we'll end things with an open discussion where you can ask questions, all things Dapr, and we'll try to make time for asking questions throughout this call today. So if you do have questions at any point, please use the chat to put them in there, and we'll make sure we cover those as we go. And without further ado, we can get into today's first topic, which is KubeCon EU 2023. Mark?
Yeah, I'll take it away. I'll share. I'll share my screen. Yes. So hi everyone. I'm Mark Duiker, one of the Dapr community managers. Talking just briefly about Dapr at KubeCon EU, which was 2 weeks ago. It was sold out, so this was pretty busy there. But I think we had a good presence there at KubeCon. So it started one day before the actual event, on Tuesday. Whoever is not muted, could you please mute?
Could you mute or Nick, if you can mute?
All right, thanks. So there was the Dapr project meeting on the Tuesday morning, very early in the morning. Mark volunteered for that to go out of his bed super early and to give a Dapr update. But given the time, it was actually well attended. So thank you, Mark, for doing that. And then on the second day, all of the incubation products gave a product update. Which was another challenge for Mark because that update had to be done within 45 seconds. So we recorded that like 1 week before. But yeah, we had a lot of eyes on Dapr during that moment, which was great. Then were 2 Dapr-related talks. There was one by Mauricio Soltino from Digrid, Adrian Cole from Tetrate, and Tai Xiang from Intel about safe dynamic middleware with Dapr and WebAssembly. So it was a really cool talk. And by the way, the links here also share the slides as well, but the links point to the YouTube videos you can rewatch in case you missed it. And the second talk was by Shubham Sharma from Microsoft, building high throughput applications with bulk messaging in Dapr. So two really good in-depth topics. So definitely see more of that. Well, here we see Mark and Ron just posing with some kind of CNCF mascots over there, but that's not only what they've did, right? We've really talked with a lot of people there. And actually, a lot of people are actually either using Dapr or maybe doing a trial with Dapr to see if they can use it. So we were actually positively surprised that a lot of people are actually using or considering Dapr. So that was really great to hear. So I think overall it was really a good event for everything that revolves around Dapr. Any questions, suggestions, additional remarks from people who were there?
Yeah, so I have 2 remarks. So first of all, yes, I was pleasantly surprised, and this is your own, by the way, I'm pleasantly surprised with the amount of people that, knew Dapr and were actually using Dapr. I think there was a really nice increase from last KubeCon. And so the level of awareness was definitely felt. And I think this really correlated with the latest SynCF project usage survey that showed that Dapr is used in 10% of all production workloads in SynCF. That survey had over 2,063 individuals, unique individuals from unique companies surveyed. And yeah, that was really great to see, and it was definitely felt at KubeCon. And the last thing I'm going to say was that that zebra felt very suspicious to me. I felt threatened by it, and this is why I'm giving it a very weird look here.
Thanks, Sharon. Right. Back to you, Nick.
Thanks. Okay, I think next up we have Samantha, I believe, who's going to talk a little bit around a new feature that's being introduced into Dapr 111, which is the service invocation capability of calling non-Daprized endpoints. With that, you have the screen.
Okay, cool. So let me make this big screen for everyone. Can y'all see my screen?
Yes, we
Yeah,
can.
I see the slides.
Okay. View, slideshow. Okay. So yeah, I'm Samantha Coyle and I go by Sam. I am a software engineer at Diagrid. Recently, I had the honor of working on service invocation for non-Daprized endpoints. And so before I go into it, it's important to kind of highlight some of the motivation and why we looked into this feature. And so the Dapr philosophy, right, is all about those incremental changes and supporting our developers and community. And so in the case that you're in a brownfield scenario where you might have some non-Daprized endpoints, well, you want to be able to invoke them. And so that's where this feature is coming into play. So, oh, wow, I just realized I'm like looking at myself. Okay, so to talk about the service invocation capabilities that exist today, you get a lot with it, right? You get resiliency policies where you can have retry and back off and circuit breakers. You get observability with tracing and metrics using some awesome open source projects such as Zipkin. You get access control through identities, middleware, security or service discovery, and end-to-end security with MTLS. And you can see there at the bottom, there is an example of a checkout service with its Dapr sidecar interacting with that order processor service and its Dapr sidecar. And so, oh wow, okay, there's a lot of animations. So with the existing service invocation API, you get a lot with it. And one of the really niceties here is this consistent URL format. So you'll see down at the bottom, there is the HTTP localhost 3500 v10 invoke for the order processor service, right? That app ID. And we're invoking method orders. So it's that checkout service interacting with that order processor service using its app ID. So that's using the existing service invocation API. Now, wouldn't it be nice if there was a world where we could use the same consistent format for non-Daprized endpoints? Well, currently it is not easy, right? So currently with the service invocation API, you can't interact with non-Daprized endpoints. So the community has looked into different workarounds so that they can interact with non-Daprized endpoints. And so one of these workarounds was an HTTP binding, which was pretty constrained, meant additional overhead in terms of defining another component. And it was missing a lot of the regular service invocation API benefits, such as resiliency and some of the other benefits, right, that you inherently get with the service-to-service invocation API. So we looked at, well, what were the benefits with the existing service invocation API, and how can we use those for non-Daprized endpoints? And you can see here, it's the regular service invocation API benefits and what we wanted for non-Daprized endpoints. So we wanted that resiliency policy with the retries and backoffs. We wanted observability and access control through scopes, middleware, and that service discovery. And so for this V1 implementation, we do have some of your basic authentication, such as using tokens or passwords for your requests. And what this enables you to do is have something like that checkout service with its Dapr sidecar that we've seen in some of these past slides. And you see there, it's sending a request to a non-Daprized service or a non-Daprized endpoint. And so that meant a few changes. So we've kind of called it the Service Invocation API++, because it's the same look and feel, right? You have the typical URL. So that first URL is a get HTTP localhost 3500 v10 invoke to the app ID. And then for method orders. But we've added 2 alternative options so that you can invoke non-Daprized endpoints. So now you can place a URL directly here, or you can define a new Dapr resource called an HTTP endpoint and place the name of that resource here. So it's important to note that this is in preview functionality for 1.11 when that does get released. And again, this is a new Dapr resource that we've defined to enable this capability. And so what that Dapr resource looks like is it's of kind HTTP endpoint. You can see that we've named the example on this slide GitHub. And this example on the slide is consistent with the demos to come. So just keep this in mind, but I'll show it again here in a bit. And you can see that I have a spec with the base URL defined as https api.github.com with a few different headers to include authorization using a secret key ref pointing to my GitHub token. And then I'm using a secret store. So you can put in whatever headers that you want here that are your typical HTTP headers that you see. So accept language is a pretty common one. As is authorization. So I just put those there as examples. But there's other fields such as scoping if you want to add scopes to this HTTP endpoint resource. So for what that looks like visually now, I want to show you with a Node app that has a Dapr sidecar, and it's sending a request to a non-Daprized endpoint. And so I put GitHub there because I'm telling Node app to invoke that GitHub API using the HTTP endpoint that I showed y'all in that prior slide. And so visually, this looks very consistent with what you expect from the regular service-to-service invocation API, as well as if you look at the URLs, again, it's really consistent. So in this first URL, we're using the named HTTP endpoint. So you can see that here with GitHub in bold. And I'm invoking repos, Coyle, Seguin Volleyball. So that is just a random repo that I have privately on my GitHub account. So I've used a private repo because I wanted to show off the headers working as well as a secret key ref working. And then you can also see if I want to place the URL directly here, you can do so as well. So I'll go ahead and get into a demo. First, I'll start with a standalone Dapr running just locally on my machine with that Node app that I've showed y'all, invoking an external request to the GitHub API. And then I'll move into a Kubernetes environment doing the same. Minimize that. Get rid of that. Okay. So just to get everyone on the same page, I'm in, hopefully everyone can see this easily. Or do I need to zoom in?
I think it's good.
Okay, thanks. So you can see here, it's pretty much the same thing that we saw on the slides. It's an HTTP endpoint, new Dapr resource. And we decided to add a new Dapr resource because we didn't want to keep adding on to the existing ones and really bulking them up. And it kind of made sense to make its own. So you can see here, this one's named GitHub. It's pointing to this base URL with a few different headers to include a secret key ref to my GitHub token. And in this case, because I'm running it locally, I'm using a local secret store. And then you can see here, I have my secret store called local secret store. That again has my GitHub token in a JSON file. So hopefully I don't share that with all of you here today and have to create a new one. And let me make this a little bit bigger. So again, this is just a Node app that I grabbed from the Hello Kubernetes example in the Quick Starts repo. And it is the app.js. So I just added a few things to it. So you can see here that I have GitHub, which is me saying, hey, I'm going to use the HTTP endpoint name. And you can see here that same URL that we've been seeing across the slides. So it's HTTP localhost 3500 v1 invoke. So here's where I'm placing GitHub method and then repos to my repo called Seguin Volleyball. Just, I don't know, I was in volleyball league here, so I made a repo for it for some stuff. And then I have an endpoint to invoke using this HTTP endpoint resource. So that's one way of using it. The other is if you place the URL directly here. So you can see here that I just have api.github.com and I'm placing it directly in the invoke URL. So it's localhost 3500 v10 invoke, and then I've placed that URL directly here. Method users, and I just arbitrarily chose that endpoint so I get some data back. All right, now if I don't, give me 1 second. I don't know what I clicked. So my terminal is looking a little weird. Okay, let me open up another terminal. And go to tutorials. Okay, and then let me grab the command. So it's a Dapr run. Oh, I can just use my history. Okay, maybe not. Okay, so Dapr run. For my Node app running globally, give it an app port. So let's just say 3000. And point to the resources. Okay, so you can see that it's running. And if I go into the logs, you can see the usual like loading components, and you can also see loading endpoints, and then it's found in HTTP endpoint. So it's my GitHub HTTP endpoint that I've defined. So now that I have this application running, I can come here. And I can do a curl. And I can see this is up and running. So I just have the ports endpoint just to make sure it's running. And now if I do invoke, you can see here, I just made a request to invoke using that HTTP endpoint running locally for Dapr. And I get some information back on my private repo called Seguin Volleyball. And again, that is using the authorization header using a secret key ref. So that was using the named HTTP resource. And then this is an example using the api.github.com URL itself. And so you can see I get a bunch of random user information from GitHub by invoking this non-Daprized endpoint. So that's all running locally. And now what I'll show y'all is get pods. So I have that same Node application running in a Kubernetes environment. I can show y'all I have the GitHub HTTP endpoint. And you can see again, it's the same thing. So I have that base URL, some header information to include my GitHub secret, So okay, git components. I have my secret store, which has my secret with my GitHub token so that I can invoke and get information on my private URL. And so now if I do, so that service I'm actually port forwarding, I believe on this terminal, so that way I can access it. And so now if I do curl to the node app running in a Kubernetes environment, let's just sanity check. It's running. Demo gods are still with me. And then invoke hub. Oh. All right. So here I just invoked using that HTTP endpoint name. So I'm invoking that non-Daprized endpoint, again, using a new Dapr resource. And similarly, I can place the URL directly into my invoke URL and get information back from GitHub for user information. So that pretty much covers most of what I wanted to share. And then I have one last thing, because we talked about a lot of benefits that come with service invocation as is. And so you can see here, similarly, you get many of the benefits, right, to include tracing. So this is the last part of my demo to show you that I did have that node app invoking that non-Daprized endpoint that I have an HTTP endpoint resource for called GitHub. And so if I click on it, I can see some information there, as well as if I go here, then I can see, okay, Node App 2 has made a few requests to GitHub, and I can get more information such as trace ID and so forth. So that's it. Thank you. And I guess just to summarize what we did here, we looked at that Node app invoking a non-Daprized endpoint through two different ways, right? Using an HTTP endpoint that I've defined. And so it's nice and declarative. So that's our preference, right? It's easy to work with, and you can use kubectl edit, update, and delete on that resource, or you can place the URL directly into the invocation URL. So thank you.
This is awesome, Sam. Thanks for showing that. It's really exciting. I think there's quite a bit of chatter in the meeting chat.
Awesome.
Folks are really excited. I think I had one question, but it seems like Kendall might have just answered it. Or actually, yeah. So you mentioned resiliency policies, and it's okay if we don't have an answer to this just yet. But how would I target one of these external endpoints in my resiliency spec? What, like, I would define a retry policy, right? And then if I wanted to apply that retry policy to this target, this external endpoint, how would that work? Do we know that yet?
Using the HTTP endpoint name.
Okay, cool. Awesome. Simple. I think, so I'll pause here and just, if anyone else has any questions that maybe weren't answered in the chat and you want to ask Sam, feel free to come off mute and we could talk a little bit about this feature.
So we piggyback on the same question that Nick made. It probably means that you can now use the resiliency policy with the API where you include the whole URL, right? Because you can now reference the URL as resiliency policy target. Is that the case?
Yeah. So I believe so.
Okay. Okay, so if you want to use resiliency, if you want to use resiliency, you're going to need to basically
The declarative way.
Yeah, the endpoint CRD.
Yeah. Cool. Any other questions from folks in the chat before we move on to the next? I think we have a little bit of time.
Yeah, I just want to say that this is a really important feature for Dapr because it helps Dapr integrate with non-Daprized endpoints, and that basically opens up Dapr to many new scenarios. I think in the student CF ecosystem, Dapr is all about integrating with existing technologies. We have the specifications that the Dapr implements, OpenTelemetry for tracing, with open metrics and gRPC and all of the other technology that the Dapr uses internally, but to make sure that it also interacts with end users' applications that have not been Daprized is, I think, really is the next step to make sure that the Dapr can operate in a much wider world than it is today. You know, if we say that Dapr is incrementally adoptable, we need to make sure that it can interact with legacy systems that have not been Daprized, or with systems that are just, you know, external to your cluster, cloud, or environment. And so I think this is really, really great because it makes Dapr not live, you know, in its own bubble.
For sure. Okay. And with that, I think we can move on to the next topic, which, if I'm not mistaken, is workflow. Nyemade, you're up.
Can you hear me?
I can hear you.
Awesome. Okay, let me go ahead and share my screen really quick. Perfect. Can you see my screen?
Yes, we can.
Yep.
Okay. Oh, my camera's being weird. I'll just turn it off for today. It's not a big deal. Okay, so today I'm going to talk about Dapr workflow. So Dapr workflows in 1.11, we have some really cool features planned. So we have an Python SDK that we're going to be releasing. So we'll now go ahead, we'll be able to support both .NET and SDK for authoring APIs. And then for management, on the management side, we'll be able to add 3 new API methods. So we'll be able to do raise event, which has been super awaited for in the community. Purge, which allows you to remove actor state from the state store, and then pause and resume, which allows you to pause and resume a workflow, so you can actually account for any type of known outages or known downtime that you might have. So these 3 APIs should be really helpful with actually helping to manage workflows going forward. Okay, so now that I've talked about what's coming in 1.11, let's go ahead and show a demo. So the demo I'm going to show today is just showing workflow durability. So the functionality I'm showing is already available. You can go and use it. It's something that is already in 1.10, but we've never actually demoed this. So what I have here is just a simple .NET console app. So in this app, you can see a bunch of different things that I can order. So I can order a computer, a monitor, keyboard, mouse, headphones, adapter, and a company car. So this is like an ordering portal for, let's say, a company for new hires that need to get their materials to start work. So I'm going to go ahead and show the durability of this workflow. But first, before I start breaking things on purpose, let's go ahead and show what the workflow actually looks like. So I'm going to go ahead and order something. I'm just going to go straight for the big bucks and order a company car. Let's do 2 because I'm a high roller. And what you see is the workflow actually kicking off. So it went a little quickly, so I'm going to just walk through what we're seeing here. So at the very beginning, we first have the workflow information here. So the workflow is scheduled and it begins. So now it's starting the process of actually ordering the car. Whew, okay, it just actually terminated. But so once the workflow is scheduled, it'll go through and basically do an authentication call here. So we're going to make sure that anyone who's ordering a company car actually is supposed to be ordering the company car.
Thank you. Okay, sure.
Would it be okay? Can we mute?
Yeah, I've muted.
Awesome. Okay, cool. So we're going to make sure not everyone can just order a company car because they're kind of expensive. So we're going to send an authentication call. So when authentication succeeds, the workflow proceeds to all the other normal steps of processing an order. We'll go ahead and reserve inventory, we'll process the payment, and then update the inventory, and then complete the workflow, which you see down here. Okay, so that's in an ideal world. So let's go ahead and go back here, and I'm going to kill the authentication server. So now it's dead. And now we're going to go ahead and order the same exact thing. So order the company car. Let's do 10 this time. Okay, so now the workflow kicks off. Again, we have the order scheduled, and then the authentication request fires, and it's failing. So it's going to keep retrying. It's going to keep trying to purchase these 10 cars for me until the service comes back up, basically as defined in the retry request. So what we're going to do here is just start up the authentication server again, And what should happen is that the authentication server is going to start up. And when we click over to the other tab, we should see the workflow eventually start to work as normally, like we saw earlier. So we see that it already has 4 retries and the workflow has now started over and, well, not started over, it's picked up right where it left off. And now it's going to the next step. It's reserving inventory, processing payment, updating inventory, and workflow completed. So this is a really cool thing just because durability is one of those things we keep getting a lot of questions around in Dapr, specifically for Dapr workflow. And we've heard a lot of really cool things of people mistakenly killing their workflow during a presentation and then restarting it, and it just starts exactly where it left off. So it's a really cool and highly anticipated feature that's already available. So, and that's it for my demo. Any questions?
Yeah, great demo. One question is this sample that you just showed something that is publicly available where folks can try it out on their own?
So currently the sample is publicly, it's in a public repo, but we're going to go ahead and push that right into the sorry, I just had a brain for it, the dapr.net repo, so you can actually access that sample there.
Can you post the URL in the link in the chat?
Yeah, let me find it. Actually, let me go ahead and push this to the .NET repo and then share that.
Okay, that's good. We can then update the community about Discord.
Sounds good.
Yeah. All right. Well, thanks for the updates and the demo. Exciting stuff. All right. Moving right along. Any other questions before we move to the next topic? I'd imagine. All right, doesn't look like we have any other questions. So, yep, I think with that, we can move to the next topic, which is Artur with the various Dapr Build variations. So, Artur.
Hey, Nick, thank you. I'm going to share my screen. Okay, can Nyemade stop sharing screen? Yeah, there you go. Thank you. Now I can share my screen. Okay, can you see that now? Yep. Okay, so yeah, build variations. So what is it? Let me start about explain the problem. So for people that have used Dapr, you might notice that all the components of Dapr are compiled into the sidecar binary. Which means that as more and more people contribute to Dapr, which, by the way, we have a successful and thriving community, the binary keeps growing more and more and more. And their components are at different maturity levels. So some of them are just getting started, don't even comply to the whole API. Some of them are already certified stable, and they all come packaged together. And some components we want to absorb, but they're still going to take some time to become mature. But it still take the binary size and also memory space when you run the sidecar, right? So in order to be able to accept more contributions from the community, and also don't compromise on having a lean binary for the users, we decided to work on build variations. As you can see today, the current Dapr binary size in master is over 150 megabytes. And the Docker image for Linux specifically is compressed, of course. So all the layers in the Docker image are compressed. Comes at a little bit over 40 megabytes for each of the architectures. So, but what we care about is the uncompressed size, because that's what actually going to be running on your machine. So what does that mean? Can we have different variations of the Dapr's sidecar and have allowed users to pick which one works best for them? For local development, usually doesn't matter as much. You can use all components and then have everything working fine without worrying about that. But when you're running in production, the sidecar image that you pick can be customized. So I work on this in the past 2 weeks for as part of 1.11. And then here's the differences. So if you look at the regular image for the nightly build that happened a few days ago, you can see how it's almost reduced by half. Okay, a little bit less than half. So we have a reduction in size in the compressed Docker image, but that's not necessarily the biggest benefit because it's compressed, you download and you can pick to cache it. The biggest change is in my opinion in the binary size. The sidecar is again almost half the size with all components. Of course, the stable components are going to keep growing just like the all components. But we expect that to grow at a different rate and always be smaller than the one with all components. So this is the first variation that we created. To use that in 1.11, the only thing you need to do is to use the -stable suffix on the image that you pick. It works for Linux only. So we're going with Linux only this time because that's where you're gonna get, in my opinion, the most benefit. We plan to add Windows as well. But for 1.11, I think they're gonna benefit users by using the Linux image. How to use it? It's a Kubernetes only benefit right now. There's not, like I said, there's not a lot of benefit to use this for local development. Although you can download the binary, the Dapr binary yourself and run the smaller version. The build variation here, you just have this annotation that you see in the bottom, Dapr/sidecar-image. That basically is the existing feature, is nothing new. And then you can pick which build variation, which image you want. In this case, I picked a nightly build with -table, and that's how I made it work. An example. What the other ways to do it? The nightly build, the latest. V1.11, any Dapr tag with -stable will work. And it was my work also to make our release pipeline, publish all of those. And that is done only for the Dapr image and the Dapr image. The control plane images don't have this variation because it doesn't have components built in, so it didn't make sense to generate different build tags for those. And as a contributor, how do I use this as a contributor? Well, when you build a component, and the last one of the few steps in the end that you have to do is to register the component in the runtime. That's done in the Dapr repository. And now every component must have the Go build tags on the top. In this example, we have all the square components, which all components must have, and we have stable underscore components. And as you might have guessed, there's nothing stopping us from adding more. So we can add more build variations, and it also allows people that want to have their own custom build to use this to make one for themselves if they want to have like a very customized variation. And what are the future variations? Well, we'll still haven't settled on this yet in the community and among maintainers, but there's nothing stopping us from, for example, having a build with only AWS components, having a build only with Azure components, or only with GCP components, or only with all the open source components, none of the proprietary products in the binary. So there are different variations we can come up with, and you can also use that yourself to build your own variation if you want in a fork. Let me move here to my screen. So I use also the tutorials for Kubernetes, and then if you look at the difference. The only difference that I made between each example is to add this tag. And then after I did kubectl apply, it's unchanged because I already made the deployment. But if I do get pods, you can see that the Node app is already running. And if we do describe pod, or describe the pod, what is the image tag? There you go. Sidecar image is running the stable image. So nothing, absolutely nothing changes in how we deploy Dapr apps. It works nicely with your existing workflow. And that's it on my end.
This is cool. I have one quick question for you, Artur. You mentioned you're customizing, users can customize their own variations through a fork, but would we ever provide a feature that allows users to say, these are the components that I'm using, not having to fork and just build a variation specific to the solution that they want, the components that they want and need, rather than just saying like, here's Azure, here's AWS, here's the ones that you showed. Let them specifically say the ones that they're using.
That is a possibility, but we don't have that in the plans. It is possible for you to build even like a web page where you can pick which components you want, click build, and then a pipeline runs behind the scenes, adding only the components you want. All that is possible. It was not in scope for this. The goal for this is to make sure that we have a path to accept new components without having a really big binary that doesn't stop increasing. So it didn't quite stop the growth, but it definitely grows in a slower rate by you allowing customers to pick the stable components. So that is a possibility that you're mentioning, but it hasn't been prioritized yet.
Makes sense.
Yeah, I think the fact it builds on Go build tags really allows this extra tooling to be written on top of it pretty easily. So if we decide to do something like that, whether it's a YAML-based tool or UI or whatever, I think it would be pretty simple.
Awesome. Well, cool. Thanks for showing that. Any other questions around the build variations? No. Okay. And so that will be preview in 1.11, Artur?
It's not preview. It's a different build artifact.
Okay.
So there's no new feature per se. It's just a matter of picking a different image for your application if you want to have a smaller binary.
Okay.
And your component's stable. If it's not stable, you have to use all of them. So
right. Okay, and then I think our last topic is some community updates via the show and tell. Mark, passing it back to you.
Yes, thank you. Sharing my screen again. Here we go. So I wanted to highlight some of the community contributions, like content contributions that people are making. So the first one is like an introductory article to Dapr from our Martino Borden. It actually looks like it's going to be like a series. He also mentioned it at the end of this topic. So hopefully next time we can also share some more articles from this person. The other one is Cloud Native Platforms by Per Ukvist. He mentions that how important platform teams are and platform engineering in general, and mentions several products, also Dapr and also Kida, that are very indeed valuable when it comes to platform engineering. It's a nice article. And finally, I don't want to toot my own horn too much, but I've created an article about how to use the Dapr.net pluggable component SDK by making an example implementation that uses Supabase for the state store, the key value store. There's a link in this article to the Git repo. So if you want to do this, play with this yourself, definitely go ahead and look at this article in the Git repo. And yeah, I like to make this like a reoccurring topic. So every community call, we can look in the Discord show and tell contributions channel, or scout a bit on LinkedIn and Twitter and see what people are creating and mention it during this call.
So Mark, if people have some content from the community that they want to have shared on this community call, the best way to do that is to add that into the show and tell Discord.
Exactly.
Channel
Exactly. Yeah, definitely.
Maybe ping you. Okay. Great. And as Mark mentioned, we'll try to make this a reoccurring segment on all upcoming community calls. So please let us know what you're building out there with Dapr. And that is it for today's topics. I want to thank everyone and all the presenters for presenting today. Really good stuff coming. And so with that, we can open it to an open discussion. And if there's anything Dapr related, feel free to either post in chat or come off mute. I'm not seeing anything, so
I'm gonna give
Yeah.
a short project update. So Arthur and I met with OSTIF today and CNCF, and we're kicking off our annually Dapr security audit soon. So that's going to be published, I think, in the next few months. And the audit itself is kicking off as early as next week, and that's going to be pretty important because, you know, of course, with Dapr being used more and more, we want to make sure that our security posture is good. And that's also a required step for us when we want to reach into and a graduated state in CNCF at some point. So, yeah.
Is that something, Yaron, that you think is appropriate to review once it concludes on the community call, or we'll just publish this?
Yeah, so there's going to be 4 blog posts, no less, that are going to come out. One from OSTIF, CNCF, the Dapr project, and there's one more body I'm forgetting that's going to release a blog post. Basically, all of them about the different perspective for the Dapr security audit, but it's going to be published. We're going to put it in Dapr Docs. We're going to tweet about it. Yes, it's going to be published in many places when it comes out.
Cool. I see Tom has his hand up. Tom, you can definitely come off mute and ask your question.
Yeah, can you hear me? Am I off mute?
Yep, we can hear you.
Oh, okay, good. Yeah, this might be a little bit far-reaching on workflows specifically, which we at my company have a strong interest in, and I'm kind of the workflow guy. Is the kind of a little bit like the Airflow model, where there is kind of a directed acrylic graph kind of integration with the idea of workflows, particularly for observability, all throughout the process, through whether it's working with product people all the way to production observation of any problems that happen. Obviously, you could do that through Zipkin tracing or some adoption. But I mean, but we're also thinking about kind of a declarative way of building workflows. So you could basically declare your workflow components and associated activities in some kind of JSON file, or maybe YAML file or component file. And then basically it would begin to build automatically a directed acrylic graph. And then it could, you know, some kind of factory pattern where basically you could crank out the workflows and activities, even though workflows and activities are very, very easy to do right now. I mean, it's amazing how easy you guys have made it. But it's a problem at our company that things that are that easy can go crazy. And we actually want to put some guardrails and controls in the way workflows and activities are actually created. So we've been kind of brainstorming, thinking of kind of a declarative way of building workflows, and also getting kind of a visual representation of them, you know, right from the beginning up, you know, all the way through a working actual workflow. So my question is, has there been any thought in Dapr about this kind of approach in this model, or am I a little bit too far reaching here?
No, hey, this is Yaron. I don't think you're too far reaching. So I'm going to answer your 2 questions about
Great, thank you.
Declarative workflows and observability. So in terms of observability, yes, we have been talking about building some sort of UI that's going to give you visibility into the different steps and activities and workflows. That's currently not planned, but it is something we talked about. Building tooling on top of workflows is definitely something we'll want to do in open source, but we need to make sure that the API is first stable, that it has all the features it needs. So it will get there, but, you know, we don't have a timeline for that yet. But personally, it is definitely something that I'd want to see in the project. As for declarative workflows, currently Dapr workflows are really modeled as workflows as code, but there is an effort going on since CF in the serverless spec working group that's trying to come out with a specification for declarative workflow model, and they're basically coalescing all of these different workflow engines that can basically implement the spec. It's not finalized yet. It's not 1.0 yet, but we have been talking about Dapr implementing the serverless spec from the beginning. So I think once we stabilize the workflows as code path, and once the workflow specification in CNCF reaches 1.0, then we can take a look at implementing a declarative way too. But again, we don't have a timeline for that, but these two things are definitely things that we're thinking about.
Oh, that sounds good. Maybe in the meantime, we will, at my company, we'll do some kind of simple prototyping, maybe just using the Zipkin engine, and maybe even using a workflow monitor pattern itself, actually observing, calling the Zipkin API and actually producing a directed acrylic graph for now, just to kind of put a value proposition on it in our company, at least. How does that sound?
Yeah, sounds great. And if you need any help, you can reach out to us and we'll be glad to help.
Yeah, I like the idea of actually using a workflow pattern itself to produce that.
Yeah, it sounds interesting. Be
Yeah.
sure to come on the community call and show that if you get that running.
I will, guys. Yeah, we'll put that up. Thank you. I'm done.
Thanks, Tom. Mark raises a good point that the 111 release for Dapr is scheduled for this month in the near future. So and you can look and see what's to come in the Dapr repo. There's an issue pinned at the top that'll provide an update as everything for all the things that will be released in that 111 version. So definitely check that out, and we'll most likely go over some of those big features and new things in upcoming community calls. So stay tuned for that. Otherwise, I think that's it for today's community call. Again, thanks to all the presenters and thanks for everyone for joining. And we will see you in the next one.
Thank you. Bye.
Thanks, everyone.
Thanks,
Bye.
y'all.
Thank
Bye.
you. Yeah, thanks.
Bye.